Hello, my name is Catalina Savag, and this is my report for Lab 5, Falling Slinky. This is a brief overview of what I'm going to be talking about. To begin, the objective of this lab was to predict the motion of a falling slinky and analyze the effect on its surroundings. We also compared the observed motion in Tracker with a computational model using GlowScript. The fundamental principles we used in this experiment were Newton's second law, which is a system's change in momentum proportional to the net force applied; drag force, which is a resistance force caused by the motion of an object through a fluid like air; tension, which was the force of the slinky; and the position and velocity update formulas. This is the tracker model that we used to track the motion of the slinky. Now, for the computational model using GlowScript, we had the initial conditions, which were the mass, the position, the velocity. We also had the magnitude of acceleration due to gravity, the unit vector for the positive y-axis, and the proportionality constant for the magnitude of the drag force. Then, for the first while loop, we had that W was the gravitational force, and this happened in the time when the bottom of the slinky was constant. W was the gravitational force, Ft the tension force, ball.vel the velocity update, and ball.pos the position update. For the second while loop was during the time until the slinky reached the ground. Once again, we had the W was the gravitational force, Fd the drag force, and we once again used the velocity and position update formulas. For the results, here is a graph of both the tracker data and the GlowScript data. As you can see, both of the models look very similar. The system is the spring and the surroundings the earth. One possible error could have been that the observed motion is affected by external forces not considered by the model. Another error could have been inaccurate tracking point placement in the tracker software. Finally, we can answer the question, does the bottom of the slink remain stationary? The forces in the y direction cancel out, and despite that the gravitational force acts downwards, the slinky acts as a spring and counteracts the force with a tension force of equal and opposite magnitude. So yes, the bottom of the slinky remains stationary. Thank you.